Let's look at project life cycles. A good practice in project management is to break your project into phases. It's up to an organization or sometimes an individual project manager to decide what project management methodology we're going to use. And part of that is choosing a project life cycle. We're going to look at a generic life cycle to which almost all projects can be mapped. Then we'll look at specific terms we're going to use in this whole series of video clips. We'll look at the predictive life cycle, and we'll move on to the change-driven life cycles. There's quite a few phrases in the developing professional and academic literature on project management about change-driven. There's not a lot of agreement as to definitions or labels. So here on this slide, I've captured quite a few of the change-driven life cycle discussion. So most project phases can be mapped to this. This is what the project management body of knowledge calls a sample generic life cycle. And let's face it, most projects would have a phase when things are just getting started, and a phase where we're organizing and preparing, and a phase at the end which is closing. What can differ quite a bit is that big section in the middle called carrying out the work. It could just be one phase, you might call it execution, or it could be quite a number of phases. Another question is, do you have, at the end of each phase, do you have a phase gate or a stage gate or not? We'll talk about those in a few minutes. So we, in this series of video clips, we're going to assume this life cycle, and we'll use these names to be consistent with the project management body of knowledge. Now, look at these phase labels: initiating, ending in a project charter; planning, ending in a project management plan; executing, and ending in a whole handover; and closing. Now, the names of these phases are not to be confused with the names of the process groups. There is work called initiating, and it's true, during the initiating phase, you are doing a lot of initiating work. But at the end of a planning phase, you're initiating the executing phase, and at the end of an executing phase, you're initiating the closing phase. Similarly, planning, you're doing some planning while you're initiating. You're also doing planning and replanning while you're executing. And of course, the process group of monitoring and controlling definitely isn't a phase, because it goes on all the way from initiating through to closing. Oh, and we'll also be looking at the procurement statement of work. There could be one, or there could be hundreds of them, and the post-project review will be focusing on in others of these video clips. Now, there's the predictive life cycle, or also known as plan-driven life cycle. What this means is that we can plan the whole project, including scope and time and cost, in the planning phase. We understand how the future will unfold. We do not anticipate any big changes, and we typically deliver the whole result at the end. As I say, we don't anticipate big changes, and in fact, changes can be very expensive in predictive life cycles. A predictive life cycle is quite common in construction, because it's not surprising you have to do the whole design before you start the construction. In information technology and some other project types, this type of life cycle can be risky, as we don't fully know whether the result will work until the end, and the client does not see it into operation until the end. We try to address those in some of the change-driven life cycles that we'll talk about later in this video clip. So not only is the process to get to project completion known, but the nature of the work in each phase tends to be different. For example, you might have a requirements phase, then you might have a design phase, then you might have a coding phase, then you might have a testing phase. And the nature of the work is different. In fact, the people that you get involved may be different. And as I was saying, there is we deliver the whole result at the end, that's sometimes known as the Big Bang. So here's a construction example of a predictive life cycle. We're going to show the work breakdown structure of this in the next slide. And it says here that we have gates. By By a gate, we mean that at the end of a phase, there is a deliverable, and we do not proceed into the next phase until approval. Gates reduce risk. Governments, in particular, for construction projects, prefer a gated process, such as the one you see here. Let's look at the work breakdown structure. Now, you'll notice that the breakdown of the WBS at the very top is according to phases. There's the initiation phase that, if I look down, results in a project charter and an environmental assessment plan. Then there's a project planning phase that results in a statement of requirements and a project plan. Then a detailed design phase, which results in the complete design and all permitting. Now, at the end of the initiation phase, we do not proceed into the planning phase until the charter is approved. We do not proceed from the planning phase into the detailed design phase until the project plan is approved. We do not proceed from the detailed design into pre-construction until the design is complete and we have approval to proceed into pre-construction phase, where we're out in the marketplace doing procurement. And then upon award of a contract, then we start construction. So there's very clear gates at the end of every phase. Governments tend to like that because it lowers risk. It makes it more of a controlled process. Let's have a few words about a few more words about gates. When there is a gate, it's typical to ask the question, is the project still technically feasible to get the result that we intend? And are the cost and schedule still okay? Because at the end of a gate, usually there is a fresh look at cost and schedule to the end of the project. And hopefully the client or sponsor will also ask the question, is the project still justified? What about the marketplace? What about the benefits that we foresee from the project? Are those unchanged? Here's a construction project example without gates. My own projects for industry were fast-tracked, which means that upon approval of the project at the end of the planning phase, we would start into detailed design. As soon as detailed design had got far enough, we'd be out in the marketplace procuring early construction packages and then starting construction, and we'd be commissioning areas of the plant while construction was still on. It allows for a faster project, but it also is riskier because the project is approved before the design is done and when there's still lots of uncertainties. But it can be a conscious choice of a project phase, and certainly was for my clients. Here's the predictive approach to a software development project, the commonly recognized waterfall approach or systems development lifecycle. The PMBOK guide says that predictive life cycles are generally preferred when the product to be delivered is well understood, there is a substantial base of industry practice, or where a product is required to be delivered in full to have value. In a lot of software development these days, there is a marked move from the waterfall to agile development that we'll come to later in this video clip. Then separate from the predictive life cycle are the change-driven life cycles. And as I was saying, there's a lot of terminology that professionals and academics are using here. It can also be known as discovery-driven or empirical. And the change-driven life cycles, as you would expect, adapt to change more easily. They can be iterative, where each iteration, an iteration is a phase. Each iteration repeats some project activities, and as we go from phase to phase, the understanding of the product increases. There can be feedback after each iteration, feedback, for example, from a client. The change-driven life cycles can be incremental, where each increment, the increment is also a phase or an iteration. With each phase or increment, there is in fact a usable product, so we can get something to the customer that they can use earlier than in a predictive life cycle. And there's also agile, which is considered to be iterative and incremental. So here's an example from new product development. I think this is sort of partly predictive and partly iterative. I'm treating it here as iterative. A pioneer in new product development research is Robert Cooper from McMaster University. And in 2010, a benchmarking study revealed that something like 90% of U.S. businesses that have new product development use a stage gate system. It was reported in this benchmarking study that they claim to have benefits such as improved teamwork, shorter cycle time, improved success rates, earlier detection of failure, a better launch, and shorter project duration. So the concept here is that somebody has an idea for a new product or an enhancement to an existing product. That idea goes through a gate. Questions are asked, fairly high-level questions, like, is this consistent with corporate strategy, or do we have some reason to believe that there could be acceptance by customers? If it passes the gate, it goes into project scoping, and then we have several other gates. At each gate, as we proceed through the process, the questions become a bit more rigorous and get into things like net present value. Now, at any gate, the decision can be made to, yes, pass it into the next phase, or bounce it back to the previous phase for more work, or put it on hold. If it's on hold for too long, that is the equivalent of cancellation. So here's another example of iterations. This would be iterative planning, known as front-end loading. It came out of, as far as I can tell, it came out of DuPont in its chemical plants in the 1950s as a way to, they were doing research and development on project management processes. And they found that putting more emphasis on planning, in fact, there'd be three successive phases of planning, sometimes known as FEL1, FEL2, and FEL3. One of my clients calls those a scoping study, a pre-feasibility report, and a technical feasibility report. The first of them has some technical deliverables, but also a project charter. So with approval of the project charter, we move into the second phase, leading to a pre-feasibility report, which would include a lot of engineering deliverables, but also a preliminary schedule and estimate. Approval of the pre-feasibility report would take us into the third phase, where, again, there's lots of engineering done, but there's also a definitive estimate and a project management plan. So and each of these flags is a gate. The project does not proceed further until feasibility looks good, cost and schedule still look good. It provides more control. Another one of my corporate clients who was adapting this process said that after the technical feasibility report that they anticipated to bring in the project plus or minus 5% on the budget. That seems a little optimistic. And with zero scope changes. We know that zero scope changes is definitely overly optimistic. Here's an example of an incremental life cycle. So your project is to rebuild old screw pumps in an effluent treatment plant. The plant has 8 of them, but it only needs 6 to be in service at any one time. So we get ready with the plan and the parts for one phase to rebuild just 2 pumps. Then we dedicate a phase for those 2 pumps. We take them offline, we tear them apart, we rebuild them, and we put them back online. Now, in that phase, we know we're going to replace the bearings. We also know we're going to inspect the gearbox and the motors and the screw pump bodies, but we suspect they're all going to be okay, or at least we're planning for them to be okay. If they're not okay, then if it takes longer, well, that phase takes longer, and we can replan for the subsequent phases. Or maybe we find out that in that first phase with pumps 1 and 2 that the pumps are not repairable. Well, that's okay. We've only wasted our time with 2 pumps. So we can now plan a replacement strategy for the remaining pumps. You see, we enter into the project just committed to 2 pumps. And whatever we find in each of these incremental phases, we can learn for future phases. And as with any incremental project, the customer could decide at the end of when they get pumps 1 and 2, or 3 and 4, or 5 and 6, they could decide to terminate the remaining work, or postpone the remaining work. And also, as with any incremental project, at the end of every phase, the customer does get some finished product that provides them some value. Now, it's been growing of interest in software development over the past 10 or 15 years, the concept of agile project management, which is considered a change-driven approach, sometimes called adaptive. And here there is some planning, and there's phase, and there's a closing phase at the end. But I'm looking at that middle portion, carrying out the work. And in Agile, we plan for a number of iterations of a fixed duration. That fixed duration might be 2 weeks, or 3 weeks, or 4 weeks. And we start with creating a list that we call the backlog. It's a list of requirements or features, and we group those features into successive iterations. And then we go into the first iteration, and we do our further requirements. We do design, we do development, we do testing, and we have software code or some other product which could be used. In this case, maybe the customer is not using it. Then we go into the next phase, and the customer or ourselves can rearrange the backlog. So we choose at the beginning of each phase what are the requirements or the features we're going to design, code, and test in the next phase. So at the end of the second phase, then we have more code which has been tested, and in fact, perhaps here we're actually going to release it to the customer, and they can start to get value out of it. And then we continue into successive phases. So it's very adaptable to change in the requirements or change in the environment. It allows the customer to decide when they want to stop. Maybe the customer, after they get release 3, might say, hey, I like this product. I don't think I need release 4. Thank you very much. The documentation is very light, much lighter than in predictive lifecycle. And as I say, it adapts to changes very well. You can refer to the PMBOK guide for a brief discussion of predictive versus the change-driven life cycles. So this was our discussion of a generic project life cycle, the predictive life cycles, and the change-driven life cycles.